Hello and welcome to Quesadilla Math with me, Mr. Padilla. Today we're going to be talking about domain and range of functions and how to write domain and range of functions using interval and inequality notations. So let's get started. Today we'll be using the Desmos online graphing calculator to help explore domain and range just a little bit. Here what we're looking at is a linear function, although it's probably not what you remember from Algebra 1. In Algebra 1, most of the linear functions that you used had an infinite domain, meaning that they went on forever. Any value for x could be used, and you could get any value for y. Now we're looking at a function, a linear function that has actually been cut down. Okay, it has a starting point and an end point. Now remember that the way we read a function is from left to right, so our starting point will be the leftmost point here, the one that says included point. We'll talk about that in a minute. And our end point is the one on the right, which is, in this case, our excluded point. Let's go ahead and discuss what we're looking at here. So these endpoints are going to be very important to notice. A closed point is actually what we call it's an included point. And what that means is that it's actually a part of the graph and the function overall. The excluded point, however, is, well, it's kind of the opposite. It is not a part of the graph as a whole or the function. It is represented on the graph by an open point, but it doesn't mean it's actually a part of the graph. Just imagine not being invited to a party, but deciding to go and hang out right at the front door. You're technically there, but not actually a part of the party. That's kind of how it is. Don't feel bad about the excluded point, though. Coordinates have no feelings. Okay, so now let me talk to you guys about this little shady part here. I can actually move the different parts of this shaded area using these little points here. And you might notice that the two lines that make up the shaded area, the two boundary lines, one of them is a solid line, one of them is a dashed line. You might remember that a solid line means that it is included in that set of numbers. Our dashed line, however, is definitely not a part of the shaded area, but it is the boundary, much like our excluded or our open point. Let's go ahead and match those up, and in doing so, we will shade in our area. Now what we're looking at is the area as far as the x values go, as far as our domain goes. Domain, x values, these things are interchangeable. So the domain of a function is really just how far left and how far right its graph goes. Now we're going to talk about much deeper meanings of domain as we go forth. So in this case, we can say that we use the x values that are included within this shaded area. In this case, we can actually look at the shaded area and we can kind of determine that it goes from -2 on the x-axis to 4 on the x-axis. Now, of course, -2 is included and +4 is excluded. It's not a part of the domain, but it is the boundary point. So now that we can visualize what domain looks like graphically, let's learn how to describe it using different notations. So now let's take a look at domain a little bit more closely. Like I mentioned before, domain can be described graphically as the spread or the width of the graph. Think of how far left and how far right does the graph go. What are those boundaries? But we can also think of it in terms of functions. So the set of input or x values that can be used by a function represents the domain. As we start to study functions more and more and how they're used, you guys will see that not every function has an infinite domain. Not every x value can be used in every function. Since our function doesn't go on forever, not all of the x values are going to be used. In fact, we can see here that only the part that's in this blue shaded area are the x values that we're using. Let's represent this with a number line. So I'm going to start off with my leftmost point, which was at -2. Since I see a solid line on my picture here, I know that that was a closed point or an included point. So I'm going to draw a closed point right below there. Then I'm going to go to my rightmost point, and I'm going to draw an open point to represent the excluded value there at 4. I'm also going to go ahead and write down the endpoint values -2 and +4 there. And I'm also going to draw a line in the middle of these two endpoints, represented this shaded area. So what this means is that all of the values between -2 and 4 are part of the domain, including -2, but excluding +4. So now let's discuss how we're going to represent this with inequality notation. To start off with, remember that in inequality notation, we're going to use the inequality symbols less than, greater than, less than or equals, and greater than or equals. Now, these are going to be really important to recognize. When are you going to use strictly less than, which is just the less than or greater than? Or when are you going to use the inclusive less than or equals or greater than or equal? That has to do with the type of endpoint that you are describing. When it comes to a closed point, we are going to be using less than or equals, the inclusive, or greater than or equal. For an open point, we're going to be using the strictly less than or strictly greater than symbol. When I write an inequality notation, what I'm going to be using is called a compound inequality. We're trying to describe the numbers between -2 and 4. We can say that they are the numbers that are greater than -2, but less than 4. We can describe this in this way. We can say x is greater than or equal to -2, but less than +4. So we use the same values as our endpoints in our notation, and I want you guys to notice that I use a less than to describe our excluded point and our less than or equal to symbol to describe our included point. Now, I want you guys to notice as well that I only use them less than. When we write an compound inequality, we use less than symbols, not greater than symbol. So now let's discuss how this works with interval notation. Interval notation uses these symbols, brackets and parentheses, to describe whether or not we have included or excluded endpoints. Interval notation describes values in between these two endpoints. So let's go ahead and take a look at how we would describe this. Now, brackets are going to be used for included points. So those all go together. Parentheses will be used to describe excluded points. So these symbols go together. So let's go ahead and use the same numbers that we use to describe our domain for both a number line and equality notation to describe it in interval notation. So because my leftmost point is an included value, I'm going to use a bracket. Now that value was -2. I'm going to write a comma in between. And I also have my right endpoint was 4, and that is going to be an excluded point, so we use a parentheses. Really, both of these types of notation describe the exact same thing, just in a slightly different format. Mathematicians, math teachers especially love to use interval notation. However, a lot of programs, including Desmos, prefer using inequality notation. So now let's discuss the range of a function. So the range of a function is going to be a lot like the domain. We are also going, instead of going from left to right like domain, when we're looking for the range, we're describing the function from its very bottom to the top. So whenever I think of range, I like to think of Drake. Started from the bottom, now we here. Sorry for the bad math joke. So just like before, our solid line represents a solid point, a closed point, an included point. And a dashed line represents the excluded or open point. So I'm going to go ahead, I moved those boundary lines there, and now I can see the shading is going between 0 and 8. So now let's go ahead and just take a look at how we write the range of a function. So much like before, let's get a better definition of the range of a function. Even though graphically it is the height of a function, you can think of it that way, the bottom to the top of the function. how far down, how far up the graph goes. In a better sense, the range is the set of all output or y values a function will produce based on its domain, the x values. Like before, I'm going to start off by making a number line. I have my closed point at the bottom, so I know it's included. That happens to be at 0. And I have an open point up at 8. Line connecting them because it is shaded all the way through. So I'm going to go ahead and write it horizontally to help myself. Remember, we're going from bottom to top. That means left to right. It's going to be solid at 0, open at 8. And now we can use this to write our inequality notation. So I know that in inequality notation I'm going to be using less than or equals in included inequality for 0 and strictly less than for 8. It's going to look something like this. X is going to be greater than or equal to, kind of read it from the inside out, 0, but less than 8. And in interval notation, I have to remember that a closed point is a bracket and an open point is a parentheses. So here our range is going to be from 0 to 8 with a bracket for 0 and a parentheses for 8. Now, I hope you guys were paying attention because I made my first mistake of the year. There's going to be plenty of them. See, the range is the set of y values, so when you describe them, you have to use y instead of x. So now we have found the range of our function in both inequality and interval notation using the right variables this time. Alright, let's look at our next example. So now we're going to look at an example where we have to find both the domain and the range of this function. It's no longer a linear function, so it might give us a couple of headaches. Let's see if we can avoid those. So I'll start off with a domain. Now on my left side of my graph, I see that I have an open point, so I'm going to use the dashed line. Place it right on top of the open point. Looks like it's at about -2 on the x-axis. And the solid line is going to intersect with the solid or the closed point down here. That looks like it hits at about 4 on the x-axis. The domain was not too difficult to find, but I do want to point out something with the range. So the range, again, I'm going to start at the very bottom. There's a solid point here, so I'm going to put the solid line on it. And this is where I see a lot of people make their first domain mistake, or in this case, a range mistake. I see this a whole lot, where people see the end point of the function and they assume, well, that must be the top of the graph. That's where I should stop my range. But if you notice, there is still a bit of function left on top, so I need to go ahead and make sure the entire function is covered. And it looks like it goes all the way up to 9. So let's go ahead and take this and write our domain and our range in interval and inequality notation. Okay, so as you guys can see, we've kind of placed our function, our graph, in a little box. So now we can kind of use that box to help us describe it. I'm going to go ahead and draw some number lines here to help us represent our domain and range. We start off with a domain with an open point. Looks like it is at -2 on the x-axis. And stops at a closed point here, which looks to be at 4. Go ahead and connect in between. My range at the bottom, solid point. And up at the top, even though there isn't an endpoint like nice and big and easy for you to see, there is a point at the top. Now, any part of the line is considered a closed point, is considered included. So even if it's just a part of the line, or the curve in this case, that's our top, it is considered a closed point. So I'm going to go ahead and make a closed point here. This one is at 9, and it looks like the bottommost point is at -7. So I will go ahead and connect in between. Since it is all shaded in between, we're good to go. And let's go ahead and write our domain and range. So for our let's start with inequality notation. So for our domain, I know we're going to be using x values here. I know that it is going to be less than -2, a less than symbol once again, because we are dealing with an excluded point, and less than or equal symbol for our rightmost point at 4, since it is an included or closed point. Now for our range, let's look at our bottommost point, -7. It is a closed point, so we're going to be using less than or equals. Since we're dealing with the range, we're using y. And again, our topmost point is at +9 on our y-axis. Let's go ahead and convert these over to interval notation. In interval notation, very much similar. We're going to use -2 and 4, our endpoints. Since -2 was not included, we'll use parentheses. 4 was included, so we'll use a bracket. For our range, both of these points are included, so we're going to use brackets for both. -7, our bottommost point, and 9, the topmost point. Remember, from bottom to the top for range, left to right for the domain. Alright, let's look at our next example. So now we're going to be looking at what's called a piecewise graph, which is really just a function that's made up of other functions. So I like to think of it as a Frankenstein function. We'll be talking about these more as we go forward. So let's go ahead and analyze our graph and adjust our shading for our domain and range. So starting with our domain, I see that we have on our leftmost point, we have a closed point. So I'm going to take the solid line, stretch it over to there, and I'm going to go ahead and take the dashed line, stretch it all the way to our open point. Now, the range, let's start with the bottom about right here. Even though there is a open point here, the rest of the bottom are made up of closed points, solid points included. So we can say that it is included at this value. And it goes all the way up. Let's see, is this the top of our graph, just like the last one? No, it looks like there's a little bit left over. So we need to go all the way up here. Alright, let's go ahead and write these in our new notations. Alright, now that we have boxed in our function, let's go ahead and turn our domain and range into number lines that we can use. So starting with a domain, I'll start with the leftmost point, which is a solid point. It looks like it is at -7 on the x-axis. My rightmost point is an open point, and it looks like 5, 6, 7, 8, 9 on the x-axis. And of course, we are connected all the way through. Now for our range, it looks like we start at the bottom. Once again, even though there is an open point here, the rest of the points at the bottom are closed, so that overrules it, and it is a closed point down at -4 on the y-axis. And our topmost point is this solid point here, so solid point at 6 on the y-axis, connected all the way between. So now we can pretty quickly write our domain and our range. Let's start with the domain. So in inequality notation, we would say that x, since my leftmost point is solid, I will have less than or equal symbol here. So it's -7. And it goes all the way until 9 with a strictly less than symbol for the 9. In interval notation, I am going to have a bracket for my closed point at -7. And for +9, I'm going to have a parentheses to represent the open point. For the range, it's going to be very, very similar. In this case, it's going to be -4 less than or equal to y less than or equal to 9, since, whoops, not 9, 6, that's the second mistake of the year. And the range in interval notation is going to use both brackets again, -4 to +6. Let's take a look at our last example. Now for our last function, we're again looking at a piecewise function, but this time it's a disconnected one. We call these areas where the graph is not connected discontinuities. We'll talk about that as we go further in these videos. Now, of course, this graph in technical terms looks like a crazy mess. That's because we have several different domains and ranges we actually have to look at here. So let's start with a domain. Now, here I see there's 3 pieces of graph, and it looks like there are 3 different domains I can choose from. Now I'm going to start with the leftmost part of the graph here, this linear piece of function. And I notice that both the endpoints are open. So I'm going to use the set of domain shaders that have 2 dashed lines. Now the second one is 2 solid or closed or included points. So we're going to go ahead and use this blue one that has 2 solid lines to represent the domain here. And our final piece of graph, luckily, has 1 solid and 1 open point. So let's move this into place. Now for our range, now you'll see there's 2 different sets of range shaders here. One that has a dashed line and a solid, the other one with both solids. So it looks like if I start from the bottom, this part of the graph does not connect vertically with these graphs up here, and it starts off with with an open point and stops at a solid point. The next part of the graph, there's nothing in between this value here. There's no graph in between this value here and where this one starts down here. So I'm going to go ahead and put my solid line on this closed point. I'm going to stick with using this graph because it goes all the way up to this value right here. Now you might be thinking, well, since the domain needed 3 separate domains, why doesn't this graph need 3 separate ranges? Well, if you notice, even though there's 3 pieces of graph here, this quadratic, this little curve graph here, actually is large enough to cover up the third graph, that little linear graph here. So because of that, we don't need to use a third set of we don't need to use a third set to describe a range. We can use just 2 and it'll cover our basis just fine. So let's go ahead and do that. So starting off with a domain, you might notice that there are 3 separate number lines that describe the domain of it, and these different number lines don't exactly connect. So we're going to have to actually write 3 different inequalities to describe the domain in this situation. Let's start off with the very most left set. So these are open points, so we're going to be using less than symbols here. So it's going to be -5 is less than x is less than -2. Now, in between our 2 sets, we're going to write the word or. Let's look at the next one. Next one we have 0, which is a closed point, so less than or equals. And 4 is also going to get less than or equals. So we'll have 0 is less than or equal to x, which is less than or equal to 4. Or, now for our final one, both closed points, actually, not so. 10 is an open point. Good catch there. Always look out for mistakes. It can happen to anyone. I'm trying to show you as we go along. That's mistake number 3, if you're counting, by the way. Here we have less than or equals, and then strictly less than for our, yes, open point. And so this is going to look like 6 is less than or equal to x is less than 10. Now, in interval notation, we're going to do this very similarly. Once again, open points are parentheses, closed points are brackets. So we can start simply by writing parentheses -5, comma, -2. Now, instead of using the word or in interval notation, we use a U symbol. The U symbol stands for union, which is basically a fancier way of saying or. So after the union, I'm going to go ahead and make my next interval. This one is from 0 to 4, both with brackets. And then another union, and I might need a little more space here. Oh, you come too. And this one is going to go from bracket 6 to 10 with a parentheses at the end. Just squeezed it in. Alright, now let's talk about the range. So now for the range, we're going to look at the bottom piece, and we can see that it starts down at -4 on the y-axis with an open point up to -2 with a closed point. Then we have this space in between where there's no graph to be found, and we start over with a closed point at 0, and it goes all the way up until a closed point. Remember, a line or a curve is a closed point up at 9. So we're going to describe our range the same way. This is going to start off again from the bottom, -4, strictly less than y, less than or equal to -2, or 0, less than or equal to y, less than or equal to 9. In interval notation, this will look like parentheses -4, since it's not included, comma, -2, with a bracket because it is included, a U for union, and then we have, bracket 0, comma, 9, with a bracket once more. Thank you guys for joining me for learning about domain and range using inequality and interval notation. This is the standard for Algebra 2. We're going to be using interval and inequality notation to describe a whole lot of things, including domain and range, for all the different types of functions that we're going to be studying this year. This does not go away. This is incredibly important to learn for people who are going to go on into calculus, who want to become engineers, computer scientists. This using symbols to describe things just goes on and on and on from here. So, as always, please leave a like and subscribe so that you can get access to future videos and continue learning Algebra 2. And as always, I will math ya later.